Hi everyone, I'm here to talk to you about enhancing spatial reasoning utilizing a hybridized field course model using examples from the GeoSPACE field program that I'm more than happy to answer questions on in general. So spatial reasoning within the geosciences is incredibly important as it allows us to interpret and understand the physical world and processes that are around us. So it's really important for us to be able to look at information, to visualize and understand the patterns that we're observing, and being able to look at those patterns and understand how it relates to the textures that we see on Earth's surface, and then being able to relate that to the structures and the processes that we're being able to see, and using different cues and information that are really useful, such as the color and the space that they occupy, to really understand how this is impacting not only the landscape, but our understanding of that landscape overall. And these observations can be taken from a wildly different perspective, either from a top-down perspective using remote sensing, or from a bottom-up perspective using traditional field methods. The GeoSPACE program is a great program for geoscientists promoting accessible collaborative experiences, and it is a completely accessible and inclusive planetary and volcanology field course based in the San Francisco Volcanic Field that's developed by faculty and early career professionals that that identify as having disabilities and do not identify as having disabilities. This is a one-of-a-kind field program that ran in 2022 and 2023. Shameless plug, we're looking for applicants for 2024. And we're utilizing a hybridized field course model. So our approach is that we have virtual participants that act as mission control, and we have our in-person students are acting as astronauts that are going to explore the field site. This is completely collaborative, where we use synchronous and asynchronous communication technologies, everything from Zoom and Discord, and just text messaging and other types of technologies in general. This serves as a model for future field experiences that incorporate virtual participation within our field course model, so definitely check it out. Feel free to find us on X, formerly Twitter, at the QR code here, or find us in general. We're at the conference. So our hybridized field course model with our mission control students, these are our virtual participants that are very much using a bunch of different technologies to interact and engage with our field sites. So everything from JMARS, Google Earth, and along with a suite of different platforms for communication from Zoom, Google Suite, and even OneDrive to share large data files. Our mission control students, what they are doing is they use spatial data to perform an analysis before our in-person students, our astronauts, go and investigate it. So we provide them with a bunch of different data sets for them to visualize and analyze the field sites before our astronauts will go investigate them. They're interpreting superficial features through visible imagery, hyperspectral imagery, and three-dimensional data elevation models. Along with, they present our field site to our students, providing context before they enter in the field, and then pose questions for our astronauts to go explore while in the field setting. Our students in general, from our mission control perspective, are fully engaged in the course, but they are very much so limited by the resolution of the data and the spatial scale that's required for them and requires them to have data collected in the field to have a better understanding of the fine scale features that are going on. Our astronauts, on the other hand, use traditional field methods after their mission control briefing when they're going to investigate these different sites. They are collecting samples, they are sketching the field sites, they're using photography skills to take pictures of samples, they're using UAVs and photogrammetry to model our field sites in general, and they're also presenting our findings in the field to our mission control team as well, and answering questions that our mission control may have after visiting these sites. Our students that are in the field are also limited in some ways because there's only so much of the field site that they're able to see from the ground perspective, and they require that top-down perspective to provide a lot of the context they might be missing on the ground depending on where they are. So they may not be able to see the whole picture. And spatial reasoning in our field course was incredibly beneficial for students to not only engage in our field sites, but really to make the connections between different types of data and the samples that they were collecting in the field. So data that was acquired by our astronauts facilitated spatial data visualization and reasoning skills for our virtual students or mission control. Basically, our in-person students would go out into the field after their briefing, collect the samples, and our mission control group would actually be modeling or mapping out where these samples were collected from, providing scale and context to where these samples were acquired. It also is exposing our students to modern geotechnical technologies and enhancing critical reasoning while engaging with our field sites. So for example, why does our flow go in this direction? We can have that information and knowledge that, yes, this is the extent of the flow, but now we can also see where these flows are going, the different textures that are there, and really be able to share from the top down and bottom up perspectives in general. Also, our students were very much so benefiting from this hybridization approach and the flexibility of engagement as well. So they would have the whole field site for the location. Our hybridization approach broke them into two groups that required them to share information with each other. They acquire data in different ways through remote sensing, data visualization, sample acquisition, and photogrammetry as well to really model what these field sites were really looking like. They were required to collaborate extensively together through interpretations and investigations of the field sites, and then communicate the large-scale structures that they were seeing, along with the fine-scale data that they were observing in the field. And it really provided a lot of flexible engagement for our students in general. Despite some of the benefits, there were some pitfalls, and platform compatibility for our different platforms that we were using was a huge problem for students to investigate our field sites. We also provided them with more data than they could realistically be able to analyze, and data analysis paralysis was very much so a huge problem for knowing when do we stop looking at our field sites. Something many of us in this room, we see lots of nodding heads, we understand. Also, the social connections are very tricky to facilitate in the field with our in-person and our virtual students in general. So it's one of those things that we need to take care to make sure that our virtual participants and our in-person participants are not only dependent upon each other, but are also collaborating and building those social connections that are so valuable in our field settings. From a time perspective, it was very tricky to balance the amount of screen time that our students would have, especially since they're working across multiple time zones. For example, I'm based in New York. Our field site is based in Arizona. So, those time zone challenges can be really tricky. And we also need to take into consideration for virtual participants that may have external responsibilities that may have prevented them from going into the field. There were also other challenges, such as 2 power outages that happened in 2022 for our virtual students, along with a power outage that happened in the field as well at the hotel when I was stuck on the 3rd floor. So it was a tricky experience, right? Other challenges that were there as well were scheduling. Scheduling cannot be overestimated with the importance of having these differences in modalities to engage in our field sites. So you definitely want to make sure you're taking this into consideration if you're implementing a similar design. But these spatial reasoning skills that we're developing with our hybridized field course model was also a great way to have increased adaptability. So in 2022, we would have our in-person students that were really useful to not only be in the field, but if they were suffering illness or chronic fatigue or other experiences, they could shift from in-person to our mission control groups. In 2023, this was incredibly important due to a COVID outbreak in the field, which required all of our participants that were part of our astronaut groups to shift over to our mission control group. Although a seamless transition compared to March 2020 for many of us, there were still some challenges such as the tech setups that they would have while in the field, but this increased communication model not only allowed them to participate in investigating many of the field sites that we now had to shift from in-person to a virtual stuff, but it allowed us to really have them still engage critically with many of our landscapes and really being able to have a relatively seamless transition. And everyone in this case gained a lot of experience with looking at these remote sensing technologies and how to engage in these field sites and apply the learning that they would see from this top-down perspective to make connections with what we would see on the field. And lots of the spatial reasoning that we were developing on this field course had lots of professional development outcomes that were exceptionally beneficial for our students. So students developed a deeper understanding of volcanic processes by incorporating spatial reasoning skills. So a quote from our students that I really enjoyed was, "In JMARS, I could explore features in my own pace and learn how the appearance of features can be altered after formation." So weathering, erosion, and things along those lines. Synthesizing presentations for our mission control and astronaut groups was also critical to enhancing their engagement within these spatial reasoning processes. Putting together presentations was a fun challenge, and having the opportunity to submit abstracts to GSA, for example. Feel free to find us. There are lots of abstracts that were submitted in 2022 and 2023, and for a more robust options list, feel free to scan the QR code at the bottom to go to the GeoSPACE resource section that has lots of different things that are outcomes from students. Also, when we're working with and modeling data, the one-to-one and group guidance that was encouraging deeper understanding in the field and build confidence as well. The mentors and instructors role modeled how we think about data and we were looking at, and I now feel like posters and conferences are totally doable. This encouraged not only projects that were on Earth, but also on other planetary bodies as well. So it really provided us with a really unique way to not only engage in our field settings, but also to promote that inquiry beyond our field course in general. So just to wrap things up really quickly, just with 5 main points, hybridizing experiential learning experiences promotes accessibility while developing spatial reasoning skills in novel ways. Incorporating our mission control and astronaut learning model enhances field site analysis and interpretations, along with the collaborations between our student groups. Hybridization requires students to work together with modern technologies and is preparing them for a more modern job market. Challenges do exist here, but flexibility promotes new ways of engagement that are very familiar to our students, but also very familiar with the ways that many of us participate in our own field settings, or even our own professional lives, such as many of our committee meetings are still remote. And this model has provided students with the confidence to undertake research efforts on Earth and other planetary bodies as well. And this research does not happen in a silo, but with many of our really awesome collaborators and PIs on the project, ever from coast to coast or on the other side of the pond as well. So just to wrap things up really quickly, I really appreciate your time here at the conference. If you're interested in applying for the GeoSPACE program, feel free to look at the QR code in the bottom left-hand corner. If you want to find us on X, or formerly Twitter, you can scan the second QR code. If you want to find me on Twitter or X as well, feel free to scan the third QR code. It's the same name on the other place as well. And if you want to find more information about me or our projects, feel free to scan for my personal website. Thank you so much, everyone.
We have the full 3 minutes for questions. And we do have some time. Oh, go ahead. I can repeat your question after you say it. So just to repeat the question briefly, the question was about sustainability of a program like this, considering funding moving forward.
So we're currently in our 3rd year of the project right now, so we are looking for partners and collaborations. Feel free to reach out to us at all, wherever you find us. But we are looking for ways to have faculty buy-in along with the university system as well. So this course in general is funded by the National Science Foundation, but there's been lots of interest from the University of Florida, for example, to create a more sustainable option, along with increased partnerships between a bunch of different groups. And we're also currently in the process of applying for other grants as well to continue this project in general. So if you're interested in working with us, feel free to reach out to us. We are more than willing to. Also, the PI in the project is also in the back, Dr. Anita Marshall. Also, the lift kit is in general as well, has a lot of really useful technologies that you can use, that you can apply for in general to be able to implement some of this in your own work. So you can find the lift kit at the International Association for Geoscience Diversity booth downstairs. Feel free to find me. I'm reachable. I'm not fast. So.
It's a lending library, so if y'all can't afford the tech, you can borrow ours.
So just to say that into the mic, there is a lending library available. If you can't afford to buy the tech, you can borrow theirs. Any other questions? All right, thank you.